Welcome everyone. I hope you enjoy the lunch that Radisys sponsored. Grant Henderson, our VP, was supposed to speak. He sends his apologies he couldn't make it. Instead I have the opportunity to spend some time with you today and talk about media processing, what we've been doing in the media processing space for the past 10 years, and some of the things that we're doing into the WebRTC space. Very exciting opportunities that we see. So who here has heard of Radisys? Put up your hands. I'm going to guess that if you're in the telecom industry or the telecom side of the industry, you've probably heard of Radisys. You may have heard about some of our products. If you're from the web world, you may not have heard of Radisys. So I'm just going to spend a little bit of time introducing Radisys. We basically have three product areas. One is a series of virtualized platforms that we sell for network function virtualization. The one in the middle there is the Trillium business. Who's heard of Trillium? Trillium software stacks. So most of our investments these days in Trillium are in small cells and enhanced packet core software stacks. I'm from the media server business, the media resource function. So Infonetics has ranked us #1 supplier for media processing products and solutions for I think the past 8 years now. So you can see there's some of our customers, some are the brand name Tier 1 TEMS, as well as some of the leading voice over IP conferencing providers using our products today, and including a growing business in aerospace. So we're worldwide. We got software labs in Bangalore. We got hardware labs in China. Our head office is in Hillsborough, and we're listed we're a public company on the NASDAQ doing roughly about $250 million in revenues a year. So some of the data points I wanted to share with you. Lee Doyle, one of the analysts, thinks about, what does COTS platforms mean in network function virtualization, right? So so he ranks there, HP, IBM, and Dell, and also Radisys. You wouldn't normally think of Radisys as a COTS platform supplier, but in fact, our telecom customers view us as providing that key infrastructure to do that type of thing, and that technology is winning awards. On the Trillium side, we're doing lots of cool stuff in small cells for LTE, LTE advanced. In fact, we're actively involved in Korea, which is probably the bleeding edge of LTE deployments. All the small cell deployments going on in Korea right now are using Radisys technology. And finally, from my point of view, on the media server side, we're working very closely with one of our partners, Mavenir, on some voice over LTE rollouts. We got roughly about 20 going on worldwide with Mavenir and other partners, including the first LTE rollout, voice over LTE rollout in the United States with Metro PCS. So we talked about the voice over LTE trials. We have about 6 million ports of conferencing deployed worldwide. So the WebRTC industry, it's in its infancy and things like that. But think about that, 6 million ports of conferencing, right? That's the background that we have, and that's the expertise that we want to share with the WebRTC community into doing these types of things. So that's what we're going to talk about today. I wanted to talk about the proliferation of media processing. I then want to talk about media processing and IMS networks, and we're going to talk about 3 areas. We'll start with the basics, why it's important to decompose your applications into a media processing and signaling layer, how we can then leverage that to drive economies into your architecture, what we call the 1MRF strategy. And then finally, we'll talk about different areas where media processing is occurring in the network. The traditional IMS MRF stuff is dealing with services in the IMS core, but there's many, many more opportunities for media processing in the network. And I think WebRTC is introducing even more of those. And then we'll talk a bit more about media processing specifically in WebRTC. So the current situation is we have many mobile operators that offer a portfolio of services. So you start with the basics, the basic class 5 calling services. You might add voicemail, you might add ringback tones, IVR services, and conferencing. So typically these decisions are made in isolation when you introduce a new service. That vendor shows up and they bring their big iron, that has media processing resources. So the result is you have a proliferation of different areas of technology and different media processing elements in your network. I was speaking with one customer in Europe, and they did an audit. They identified 40 different unique media processing platforms in their network. So you think about that, 40 different technologies you need to deal with, to manage, to all that stuff. So the result is this proliferation of these media resources in the network. But there's triggers for change underway. LTE is very exciting for us because we've been in the IP media processing business forever. Up to just a few years ago when you were doing 3G, the 3G voice path is still a TDM circuit, right? So LTE is finally bringing IP connectivity right to the mobile endpoint. So it's resulting in this converged IP network for the mobile industry. So that means that you need to support voice in that network. So that's called voice over LTE. Voice over LTE is driving IMS, and IMS is driving the need for the media resource function, or MRF. So this is a 3GPP standard element that we've been working on for a while. And when I talk about media processing, I'm talking about real-time, just like WebRTC, Web Real-Time Communications. I'm talking about real-time audio and video packet processing in the network, tens of thousands of packet streams going on. How do you manage that, right? We also have video services. A lot of these old service platforms never were deployed without even video being a consideration, right? But now there's more and more video processing going on, and we're going to specifically talk about the need for VP8 and H.264 transcoding. We'll talk about that later. There's increasing needs for cloud deployment. And finally, I think the most important change that's going on is this blending of the over-the-top and the traditional telco carriers, right? So the internet users are getting telecom services from WebRTC, and then telecom service providers want to take advantage of the internet opportunities. So there's this increasing requirements for reusable, efficient media processing infrastructure. So you think about all the different types of services that you and I benefit from every day, the real-time services, starting with voice over LTE. There's a little bit of media processing even in RCS, for example, but WebRTC, transcoding, cloud media processing, messaging, value-added services. What do all these services have in common? The common denominator is they all share this underlying need for real-time, IP-based voice and video RTP packet processing. So the strategy I'm trying to advocate today is one common MRF that you can put in your network and share across all these different services, including WebRTC, leads to many economic benefits for the operators. So the one MRF strategy is, you got to deploy LTE and IMS anyway if you're into the LTE business. But as you deploy additional services, always try to rethink, I have an MRF. Why can't I reuse that MRF? Why do I need to bring another vendor into the network? So you're just trying to minimize the vendors that you're working with, reuse that, get the scale economies, no stranded ports anymore. There's so many benefits in putting that infrastructure in place. So now I want to talk a little bit about, let's step back a bit and talk about media processing, right? Media processing reuse and why we want to do that and why that's so beneficial. So I'm going to start with a very simple example. I've got an interactive voice and video response application on the left and a conferencing application on the right. And if you think about any application, you're going to have the call logic and the signaling logic and the media processing underneath it, right? But when you peel back the onion a little bit, you will see that there's a lot of commonality in the media processing layer. Playing media, collecting digits, transcoding, conference mixing and switching, bitrate adaptation, media conditioning. These are all common things that are needed by many, many services. So the call logic and the signaling logic can be very unique, but the media processing underneath has a lot of commonality. So, and the problem is, in the old days when, I gave the example of, people buying services and they would just buy in isolation, they would buy this service platform for IVVR, but that IVVR application can't reuse the conferencing resources. So if the IVVR needs to do digit collection, right, its media processing resources are busy, I can't go over to the other side of the network and use my conferencing resources. And the same with the other direction, right? The conferencing logic can't use the IVVR media processing platform. So the first thing you want to do when you architect these networks is do decomposition. And you see this across the network. This was the genesis of what was called the next generation network soft switch architecture and became the IMS architecture. Signaling is very different from the media processing plane. Signaling has different application requirements. In fact, the signaling and application logic is a much better target to do virtualization, network function virtualization, as opposed to the media plane. Look at routers, right? How many routers do you know that actually work in software, right? There's a definite need to have dedicated resources to do this media processing stuff. So we want to separate that out, and through open standards, you have these applications controlling the media processing. And that's why it was traditionally called a media server. It's a client-server relationship. The application logic was the client, and the media processing was the server underneath. So once you've done this decomposition, you can then actually merge it together. And this is when it becomes a very powerful concept. You have one media processing resource that can be shared by 2, 3, 5 different applications. So let's build this example up and look at it in a different way, okay? Most of the operators we're speaking with right now are LTE operators. So we're talking about voice over LTE and RCS. So in the IMS architecture, there is an element called the MTAS, the Mobile Telephony Application Server. That's the brains, right? That's where the call logic and the signaling is done. And the MRF is the muscle. So brains, muscle, right? So you want to do the media processing in the MRF. The RTP streams are connected to the enhanced packet core. And also when you introduce all these different systems, you got your connectivity to the enhanced packet core through the Ethernet switches. You got your management capabilities that you need to add to that, and so on and so forth. So let's start to build this out. Now I want to add new services, right? So if I wanted to add audio conferencing, multimedia conferencing, value-added services, again, it could be different business units thinking about it, different purchasing decisions, and next thing you know, you got this proliferation starting to grow in your network, right? You got all those MRF layers, you know, different protocols to control them and things like that. They all have different connections into the network. They all have different management systems. So WebRTC, you're probably anxiously waiting for me to talk about WebRTC. So WebRTC fits in here as well. It's the same idea. There's WebRTC communication services that need media processing, right? Very similar concepts to what we've been doing in the industry for about 10 years, but now there's new codecs that we need to deal with. And more importantly, for all you keen web developers out there, there's the notion of the web-friendly APIs. And I certainly embrace that. Telephony and telcos, it's all about SIP and XML-based scripting. I think where the industry's going, and certainly we've seen a lot of it at the show, is you know, RESTful APIs and JSR 309. So we need to add those capabilities as well. And finally, transcoding, right? It is critical to scalable WebRTC services, right? A lot of what we're talking about and seeing here and stuff like that, it works well in tens, hundreds, maybe thousands of ports. But if we want to really grow this industry, right, we need to embrace some of these learnings that we as an industry, the telecom industry, have sorted out for the years. And so transcoding, in my mind, is a critical thing that needs to be done. Transcoding from AMR wideband to Opus codecs on the WebRTC side, and also on the video side from H.264 to VP8, right? You know, I'm curious, I'm intrigued with the debate in the industry on H.264, VP8, should it be one, the other, both? Regardless, I think there is still going to be a need for transcoding. Even if you were to standardize on those two codecs, you still need to do bitrate adaptation. You still need to do, you know, frame size adjustments, depending if you need to go from CIF to 720p. Because mobile operators, they don't want to be pumping 2 megabits for a video into that endpoint. They can throttle it back to a smaller screen size or lower frame rate. They're going to do that. That's how we're going to save it. And the same thing with conferencing. You can't build a big peer-to-peer mesh network to get 4, 5, 6 people in a conference. The mobile operators just want one feed into that phone. That's why you need centralized media processing. That's why you need bitrate adaptation. That's why you need the media conditioning somewhere in the core, right? So transcoding it's the concept of separating out the signaling path again from the media plane. There's a lot more discussions about decomposed border architectures. We'll touch on that a little bit more in a second, as well as do you do it as a third-party call control where you're controlling that transcoding function, or do you put it inline in sort of what we call a back-to-back user agent? So the result then is we have all these different services, and the worst case scenario is each service has its own media processing resource. Each media processing resource has connections to the network. Each media processing resource has its own management interfaces and SNMP MIBs and things like that. You can't have this complexity. You can't grow your business like this, right? So that's why we're advocating work with vendors that can support all those applications, that could support all the codecs and things that you need, right? So you have, it's a multi-service MRF, multimedia, multi-control protocol, multi-codec, hardware, software, cloud. We haven't even talked about what the underlying platforms are these days. We'll get to that in a second. It's a function in the network function virtualization, and also the consistency of the media delivery and quality of service. Again, something that is a very important function of this type of equipment. Okay, now let's talk about media processing deployment scenarios. So those of you who are familiar with IMS architecture, it's the traditional role of an MRF. It fits in the core. It's doing media processing for the services. So as I've shown here, you might have your application servers, your app servers, doing your IVRs, your conferencing or multimedia conferencing, and then underneath it you would have an MRF to do that media processing, right? IMS core application. So this is something that most people recognize as the traditional role of a media resource function in the network. But there's a lot of capabilities in the products that we develop that are applicable for other applications and other locations in the network. For example, the border control function, right? There's traditionally this has been the space of session border controllers. There's a lot more interest in the industry to decompose that as well. Decompose the signaling plane from the media plane, making it independently scalable. And once you have that decomposition in place, then you can use the capabilities of an MRF type of product to provide that media plane processing. So it's IP to IP media gateways. We're not talking about traditional TDM gateways here. It's strictly IP to IP, WebRTC to H.264, for example. You then also have these media gateways that then become part of the access networks, right? Whether it's a cable access network, mobile, like 3G mobile or LTE. That's what the IMS architecture was all about. It was supposed to be one services core for any access network. That's what it was designed to do, and that's really kind of what we're trying to build out here. WebRTC fits in this as well. It's the exact same thing. You see many vendors here at the show talking about a class of product, a growing class of product called a WebRTC gateway. And that's what that product's all about, is to connect WebRTC endpoints with the SIP endpoints and provide that connectivity. And then finally, we also have the gateways into enterprise class of systems. So you can see here in summary, there's a lot of different ways that media processing resources can be used. It's more than just an MRF. It can be done in border gateway applications and connecting and media conditioning and things like that. Okay, let's shift gears now. Let's talk about media processing in WebRTC. So Radisys, we recently collaborated with Dean Bubley of Disruptive Analysis, and this is actually a chart from one of his studies on, what are all the different WebRTC use cases out there, right? And he came up with who's seen this chart before? I'm sure some of you may have seen this one before. He came up with 8 different buckets. So in the upper left is the original view of what a WebRTC was going to be used. Browser to browser, within the same subnet, it's a few lines of code, it works beautiful, right? Most web developers can develop that pretty quickly. But then continuing along that top row, you have the interconnecting between the browser and IMS, the browser to the traditional PSTN, the browser to an IP PBX. So those are interconnectivity use cases. And then the bottom are more the value-added use cases where you've got to connect into some sort of server in the network, whether it's contact centers, which I think everyone kind of collectively agrees is the obvious low-hanging fruit for early WebRTC applications. Browser-based conferencing, and also some of the verticals, healthcare, we saw some great financial examples, things like that. So if I look at these use cases, right, 7 of those 8 use cases need media processing, right? It's the same thing. There's the majority of the use cases that we as an industry are thinking about need media processing. So WebRTC will need interworking with SIP endpoints. That's why WebRTC gateways will need scalable transcoding. And I'm not talking about hundreds or thousands. I'm talking about many, hundreds of thousands of different endpoints need to be transcoded, right? You're not going to do that on a little PC that's going to sit on your desk. This has to be carrier-grade stuff, right? If we want this industry to grow as big as we hope and want it to be, we need to be thinking about these problems now, right? Media processing for WebRTC use cases. You need those web-friendly APIs. We're going to touch on that in a second. And then finally, delivering this in the cloud using virtualized or network function virtualization. So we'll start with media processing and WebRTC gateways. This is where a lot of our activity is today, basically interconnecting the WebRTC world with IMS, unified communications, and possibly even other WebRTC endpoints that need some media conditioning in the call path, right? But the challenge is there's differences in that IMS and WebRTC standards, right? We got SRTP on one side and regular RTP on the other. We've got different codecs for WebRTC that are in the standards bodies versus the codecs that the industry's been using for 10, 15 years. And finally, you got an unmanaged over-the-top network environment, best efforts networks, compared to QoS-enabled, policy-enabled type of networks that the 3GPP groups are trying to advocate. So the solution is some scalable media transcode, transrate, media conditioning element in that call path, right? So Radisys, we're working with some WebRTC gateway suppliers, providing that red box, that media transcoding, and then they add on top of that the signaling plane. So it's the ICE stun turn, it's the signaling, it's the media interworking, and together solving that connectivity problem from the WebRTC world to the carrier IMS world. Okay, so let's talk about media processing for WebRTC application developers. So there's, we're talking about adding native interfaces for WebRTC clients, no gateways, right? You're still going to need media processing for many, many use cases like we talked about earlier. The conferencing, mixing, and switching, doing that in multimedia, recording and playback, legal intercept, IVVR, right? There's all sorts of different aspects of media processing that many, many use cases will require. And then layering on top of that, the interworking, the transrating, the bitrate adaptation, as well as the media container differences between SRTP and RTP. So what we're trying to do is a media processing platform designed for rapid integration for WebRTC application developers. So here's an example here where we would have a WebRTC media processing element in the network controlled by a conferencing application that a web developer could develop. That those resources would be in the network somewhere. It could be provided by a service provider. There's a lot of discussions here at the conference about exposing those through APIs for different people to use. But basically connecting the WebRTC world to the SIP world seamlessly in one conferencing environment. So it delivers the interworking between different device and media types, screen sizes, frame rates, bit rates, maybe do some packet loss concealment along the way, maybe do some echo cancellation. Those are the types of things we're talking about. But exposing that through APIs that web developers know and are familiar with. Which leads us to sort of this roadmap vision that we're working towards, which is leveraging our strengths in the IMS side, so that's the SIP APIs, XML scripting, and expanding that into REST and JSR 309, so that we can have IMS developers continuing to use our products, a growing number of WebRTC and Java developers that will be using our products more in the future, and natively interconnecting both WebRTC browsers, SDKs, as well as the IMS clients on one side. So it's one media processing for all real-time communication development communities. So on the bottom of that red box there, I'm just going to talk very briefly about our products, and then I'm going to do a quick wrap-up. So we've been in the business for 10, 12 years now. When we started in the business, media processing was a heavy-duty thing to do. There was purpose-built hardware done in the network, and there still is demand for those types of products, right? So we offer a hardware MRF, and that has, we still recommend that to customers that are looking for that 5 nines reliability built in, and also has the best densities, right? We talk a lot about doing media processing on Intel servers and things like that, but my position is I would argue that if you want the highest densities, or if you want even the most ports per watt, people that want a green data center, there is still going to be a need for DSP media processing. There was a need in the past, there's a need today, and there will be a need in the future. But a lot of our customers are looking for software. We have a software MRF product as well, and it runs on Linux and on a variety of COTS hardwares. And more importantly, we're getting more and more into requests for virtualization, taking that technology and running that on KVM or VMware, things like that. So we're kind of working on that space. But what glues this all together is what we announced at the last WebRTC, what we call MPX operating software. So this is our common foundation that is underlying all our different product lines. So with WebRTC developers today, you obviously want to start small, so you're starting with a software MRF or the virtualized products. But when you work with Radisys, you know that you can scale to that big iron if and when necessary to provide those densities in those large WebRTC deployments that we're all hoping will come in the near future. So to summarize, there's many WebRTC use cases that need media processing, right? However, IMS interworking will be important to build that critical mass. And once that critical mass is achieved, you will need scalability, right? So that's why there exists a need in the network for WebRTC media processing, right? Real-time communications application enablement, leverage proven IMS technologies, but then extending that into the needs of the WebRTC community through RESTful and JSR 309 types of interfaces. The target markets that we supply into today and in the future include telecom TEMs, developing WebRTC gateway products, over-the-top and web application developers, as well as conferencing applications. And our product is available today, providing that scalable VP8 to H.264 transcoding for the WebRTC gateway developers. And we have lots of the other plans in place to slowly deliver some of the other elements of that vision. So my name is Ray. Thank you very much for listening. I hope you enjoyed your lunch, and thank you very much. Please come by our Radisys booth during the expo hours, and we look forward to talking to you soon. Thanks.